Okay, now a little bit more fun begins if you ask me. I'd like to share with you how valuable the graphing calculator is in terms of evaluating functions. So on your worksheet, you see this statement on about the third page, and it says to evaluate a function with the graphing calculator, you must first put the equation into your y equals editor. Next, select the second key and the table key to do a table setup. What we're going to do is we're going to evaluate these functions, number 2 and number 5, because here it says do problems 2 and 5 from the previous page. We're going to evaluate these two functions by putting in values for x, several values for x, and getting outputs automatically. So I'm going to go ahead and, here it says use an appropriate start value for x and an incremental delta value for x. Then select your second key and the graph key in order to see your table for this function. So I'd like to illustrate. So there's our two functions. And I actually am going to move this right here for the first one so you can see the whole calculator. All right. So the work here says hit your y equals editor. You see these buttons across the top of the graphing calculator. These buttons are those that will let you evaluate a function, y equals something. It will let you set up a table setup, so that you can see a table of output values from that function. You'll put values into the machine by setting up the table, and it's going to spit out values for you. So remember, we did y equals this x squared plus 1, and as I recall, we put a 3 in here and squared it and got 9, and 9 plus 1 is 10. What I'd like to do is I'd like to illustrate. Let's go ahead and type in the equation. You see this x, t, theta, n key? In our work, whenever we want to type the letter x, it's easiest for us to go ahead and grab this key than it is to go look for this letter x in green right here. In order to get that x, we'd have to hit this alpha key and then the store key in order to get the letter x. But if you just hit this key right here, you're automatically going to get the letter x. I want to square it, so I'm going to hit my squared key so you can see x squared, and then I want to add 1. So I'm going to add 1. This paragraph right here in your worksheet says, next, select the second key and the table key. So see the second key? And this table setup is what I wish. So watch this. So I'm going to hit the second key, and actually I should have maybe typed the window key for table setup. And I'm going to tell the calculator that I want to start putting in, I can put anything I want here. I could put negative numbers in here. I could tell it to start at a -5. I'm going to start it at 0. It's going to square that 0 and add 1 to it. And then see this triangle right here, delta table? That means change. Delta is a Greek letter, and in mathematics and science, we think of that as a change. So what's going to happen is it's going to start our table, it's going to put in a value for 0 of x, and it's going to evaluate it. Then it's going to go change by 1, so it's going to go up to 1. Then it's going to change by another 1, it's going to go up to 2. Then it's going to change by another 1, it's going to go up to 3, and change by another 1 and go up to 4. My independent variable is the letter x, so it's going to automatically put in values for me for x starting at 0, going in increments of 1. And then my dependent variable is y, my output. Coming out of that function machine, it's going to automatically give me values out. So I'm all set. Started at 0, go in increments of 1. See the word table right here? Next, we're going to go second and hit the graph key in order to see the values when this function is evaluated. When it puts 0 in for x and squares it, it gets 0 plus 1, gives us an answer of 1. When we take and put a 1 in for x into this equation, 1 squared is 1, 1 plus 1 is 2. If we put a 2 in for x into this equation, 2 squared is 4, 4 plus 1 is 5. Remember, put in a value of 3 for x and you get an answer of 10. 4 squared is 16 plus 1 is 17. So the graphing calculator will evaluate a function for you. So again, we did this by hand. We put in 3 squared again, 3 squared on the previous page and got 9 plus 1 is equal to 10, it's going to do it for us. It puts in 3 and it gets out 10. So look at the next equation. The next equation is right here. I'm not sure if I can see this. Let's see if I can. I hit the y equals key. I'm going to clear this whole statement right here. And I want to put into the graphing calculator, I want to ask it to take the square root of x plus 1.0604, and I'm going to close the parentheses. Let you see that. I think you can see it. Minus 6 times x cubed. Don't forget to hit this for a minus sign. Minus 6 times, here's your x right here, x to the third power. So I put that into my y equals editor for y sub 1. I've put this equation in. Now, if you recall, we evaluated that problem with a real weird number. We put in, we found g of 0.9261. And we got an answer of a negative 3.356 when we did that calculation. So I'm going to go here and I'm going to go second in table setup in order to start my table. Now if I just wanted to put 0 in and 1 in and 2 in and 3 in, then I'd go second table. And if I put 0 into that equation, I get 1.0298 out. If I put 1 in, I get this negative 4.2 in, I get negative 46. 3, I get a negative 160. But check this out. If I go second window again, and I instead arrow down to the independent variable, and I arrow to the right, I just arrowed to the right to get my cursor right here, and I hit enter. Here's my red enter, I just hit that. I'm going to have the calculator ask me for what I want to put in for the independent variable when I go to this table. So now I'm going to go second, hit the graph key, and I'm going to put in that 0.9261 that we did by ourselves earlier. And look, it gives us that answer of a negative 3.356 that we got earlier. So again, I can put a particular value in, or I can set up the table. Let's go ahead and look at this next problem. So let's look at an application. Let's say that the braking distance in feet. Now, you know, this is just a formula that I dug up from somewhere, and we don't know anything about the car. The braking distance of a car, we don't know what the tread depth is on the tires. We don't know how much the car weighs. We don't know what the road surface is like. But we're just kind of making up the fact that the braking distance would be a function of the speed with which it's traveling, the vehicle is traveling. So if I wanted to find how far it would, the distance it would take for it to stop. If the vehicle was traveling 35 miles per hour, I would substitute in a 35, square that, and then multiply it by 0.037. So again, 0.037 times 35 squared. So I'm going to go second quit. Whenever I don't want to be somewhere, I just go second quit. And I'm going to go 0.037 times 35 squared. And I find out that it takes me 45.3 feet to stop. 45.3 feet to stop. Well, what if I wanted to evaluate this function quite a few times? So what if I wanted to put it into my y equals editor? So I hit y equals, I'm going to hit clear. Be sure you're practicing with me. You really should use your calculator and learn to use it. So 0.037 and the variable x squared. I know it was supposed to be velocity squared, but I'm choosing my values for velocity, like 35 miles per hour. So I have to use the letter x. I am going to choose to go in second and hit the window key to set up a table. And I'm going to start at a speed of 0. And I'm going to have it up the increments by 5 mile per hour increments. So I'm going to have it go 0, 5, 10, 15, 20, 25, 30, 35, 40. And I'm going to come down here and I'm going to automatically have it create a table. So now I'm going to go second and hit that graph key. And look, at 0 miles per hour, it's going to take 0 feet for the car to stop. At 5 miles per hour, that's kind of like just jumping the gun at a traffic light. It's going to be just under a foot to stop. 10 miles per hour, this particular car is going to take 3.7 feet to stop. 25 miles per hour, 23 feet for that vehicle to stop. And remember, we just did the 35 ourselves, and we got this 45.3. Well, here we go. 35 miles per hour. The calculator tells you that it's going to take 45.325 feet to stop. Really a nice feature for us to be able to evaluate an equation with incremental amounts, or to have the calculator ask us what we'd like to put in. I hope you've enjoyed this. We'll probably do quite a few more in class. We'll evaluate functions for sure.